Welcome, I'm Lavinia Heaton. We're still looking at linear functions and slopes. Today we're going to look at how to graph these linear functions. So let's go back and review what we know about the slope-intercept form of a line for a few minutes. We know that means solve for y, so we have y equals mx plus b, where y has a y, or the line has an intercept of b and a slope of m. Okay, in number 7, we are going to graph y equals negative 3x plus 2. First, our instructions are to find the slope. Remember, if it's solved for y, the slope is right here, the coefficient of x. So we have our slope, negative 3. Our y-intercept is this number right here, 2, which implies we're going to graph the ordered pairs 0, 2. 2 is the y of the point, but the x is 0. So let's go to our graph paper and graph a line with slope negative 3 and y-intercept 0, 2. Okay, so we're going to take our 0, 2 and plot it. 0, 2, left or right, none, up 2, and sure enough, that's on the y-axis. So there's our 0, 2. And now our slope is negative 3. How can we write negative 3 as a fraction? Because we've got to rise and then we've got to run. Negative 3 could be written as negative 3 divided by 1, or it could be written as 3 divided by negative 1, right? So let's jot that down. Okay, let's graph our y-intercept first. 0, 2 would be right here. And then let's think about our slope. Our slope we determined was negative 3. We can write that as negative 3 divided by 1 so that we can see a rise and a run. Or actually, we could write it as 3 divided by negative 1 also to get our negative 3. So here we are on this point. I might like to choose this first form because I'd like to move down 3. So 1, 2, 3. Then with a positive 1, I'll move right 1. And there is a new point. And then from that point, I'll go down 3. 1, 2, 3. And right 1 here. And while 2 points are enough to determine the line, 3 points help me hold my straight edge a lot better. So let's see if we can graph this now into a straight line by going through our points. Okay, that's a facsimile at least, isn't it? It's not exactly the best in the world, but you get an idea of what the graph looks like. Maybe next time we'll get it a little better. All right, let's go back to our problems. And our next problem is going to be y, or g of x in function notation, equals negative 3/5 x. It's pretty easy to get the slope, isn't it? It's the coefficient of x. But the y-intercept, I don't see a number out there. What does that mean? Well, if there's nothing there, it could be because we're adding nothing, correct? So if I plug in 0 for x, I get nothing for y, or 0. So my y-intercept as a point would be 0, 0, or as our book might ask for it, the y-intercept is 0. So we're going to plot 0, 0 and a slope of negative 3/5. So let's go back to our graph paper now. Erase our former problem here. Put it back on pen. And now we will do our y-intercept, which is 0, 0. And then we'll do our slope, -3/5. So it could be -3 divided by 5, or it could be +3 divided by -5. Well, I think I'll choose the one on the left first. So I'm going to go down 3, 1, 2, 3, and right 5, 1, 2, 3, 4, 5. And there's my point. I'm getting pretty low. I don't know if I want to go down 3 and right 5 again. I think I might like to start back at 0, 0 and go up 3 using the second slope form here. So 1, 2, 3, and then we go left 5 since it's negative. So -5 there. And now we'll try again at drawing this line, going through all 3 points. Still didn't hit quite on the origin, but you get the idea. With a pencil and paper, you will be able to actually go through the points a little bit better than I'm going through them here. All right, let's go back and see what we want to do next. We're down to this one, graph y equals 4. What's different about that one? It has just a y, doesn't it? What does that mean? Well, let's see what we can do with y equals 4. Our slope. I don't see an x in there, do you? Could it be that we have no x's? That would be the same right here as this, wouldn't it? So it must be that our slope is 0 and that our y-intercept is 0, 4 in ordered pair form. So the y-intercept equals 4, which implies that we have the ordered pair 0, 4. So let's get ready and graph this one and see what kind of a line it makes. Plot 0, 4, and then if I have a slope of 0, I'll go up none and run over whatever I want to do. 0 over 1, and I draw my line. It's a horizontal line, isn't it? So when we just have y equals a constant, we will graph that as a horizontal line. And that's still a function, isn't it? Passes the vertical line test. So let's go back now. And let's think about this. Another way to look at this when we get ready to graph it is y is always 4. It doesn't matter what x is because there's not an x in that equation anywhere. So if I decide I want to graph with 3 points, I could write 4 3 times because y is 4, period. Just 4. Put in anything I want for x and then graph 0, 4, 1, 4, and 2, 4, and we'll get the same line that we had a few minutes ago. Well, now we're trying to graph x equals 0. So that is x equals a constant. Well, if y equals a constant made a horizontal line, what kind of line do you think x equals a constant might make? Sure, it's going to be a vertical line. So, and I have no y here, so I can't solve it for y and read my intercept anywhere, read my slope anywhere. So I think I'm going to go with the chart method like we did the second time with y equals 4. So I'll make my little chart here with my x's here. That says x equals 0. No y involved, so x is always 0. So 0, 1, 0, 2, 0, 3. And let's see if we're right about this being a vertical line. 0, 1, 0, 2, 0, 3. And we could keep going on and on so long as we leave our x's 0. And sure enough, going through all those points, we get the vertical line we expected to get. Okay, we've got one more situation we want to look at. Well, I can't solve this for y and put it in slope-intercept form, can I? No. No y in there. Well, if it has only an x, could we get it in the form of x equals a constant? Sure, you've been doing that for a long time, haven't you? So let's take this and subtract 12 from both sides to get just the x term. And we have 3x equals 0 minus 12 is negative 12. Check the arithmetic, negative 12 plus 12 here too, because if you choose the wrong thing, think backwards I like to say, then you can catch it here when this doesn't add up to 0. Okay, and let's change colors again. Divide by 3 to get 1x like we do, and we have x equals negative 4. Okay, that's going to be a vertical line again, isn't it? With every x being negative 4. So going back to our graph paper, we're going to do negative 4, 0. Negative 4, 1, negative 4, 2, so forth. And we have a vertical line. Now some of you will get to the point where you can just walk up and graph a vertical line or a horizontal line. You won't have to make the chart or anything. But on a test when you're under pressure, you might like to make the chart just to check behind yourself and make sure you didn't think backwards. And that's all for today.